All right, today's lesson is lesson 3, circle graphs. And I know you guys have seen circle graphs earlier in your years, 5th grade, 6th grade, but we're going to add some more pieces to a circle graph that you have not learned in previous years. So today's notes is on page 5 and 6, and the title is Circle Graphs. So one of the most important pieces about today's lesson is you really do need to understand why are circle graphs important and what do they represent. So a circle graph can represent two things. It represents 100% of the data, whatever the data might be. It always represents a full 100%. And a circle graph also represents a total of 360 degrees. So there's a lot of little pieces of information that we can pull out of data displays with circle graphs. Some of the data might represent percentages and some of the data might represent degrees. Part B. There goes the bell. Part B, what are common percentages in a circle graph? So circle graphs really do have a few types of percentages that are very common, ones that you probably typically already know. In a circle graph, if we were to cut it obviously in half, this whole half would represent 50% of the data. So 50% of the data is half of a circle. I'm going to shade that in. Now, half of that, half of 50% would be this little piece right here. Sometimes we call this a quarter of a circle. A quarter of a circle always represents 25% of the circle or 1/4 of it. And then if we were to split this 25% in half, it would look like these two little pieces right here. And these are 1/8 of a circle or 12.5%. Now, if we were to take a calculator and add all of that together, all of that would calculate to a full 100%. So a circle graph always represents 100% of the data that it is displaying. All right, part C. Now we're going to talk about the degrees a little bit. Section C says, how do you convert the percents of a circle into the degrees of a circle? Remember how up here we said that there's 360 degrees in a circle? How do we take different percentages in that circle and convert them into degrees? Step 1, we're going to set up a proportion. And the proportion that we're going to use for this is percent over 100. And again, we're looking for the percentage. Percent over 100 equals degrees over 360 degrees. This is going to be the missing degrees that we're trying to figure out over 360. So it's kind of like we're doing part over total equals part over total, kind of. All right, we're going to practice that proportion down here in part D. Part D says calculate the number of degrees. Part D, calculate the number of degrees. And the first one that we've got is just 8%. So if I wanted to calculate the degrees for that, what I'm going to do for my number 1, I'm going to use that formula right here. I'm going to put my percentage, which is 8. So 8% over 100, right? Percent over 100 equals, do we actually know the amount of degrees or are we trying to find the amount of degrees? We don't know the amount of degrees, so that's our X. And then over 360. And it's always going to be over 360 because there's 360 degrees in a circle. Now from here, this part you're really good at. We're just going to cross multiply. 100 times X is 100X. And I have no idea what 360 times 8 is. Luckily, this is a calculator activated chapter. So 360 times 8 gives us 2,880. Now we're going to divide both sides by 100, divide both sides by 100. Hundreds cancel out, and when you type that into your calculator, you're going to get 28.8. So X is equal to 28.8 degrees. So the formula is not too terribly hard. You're just working with a percentage. All right, example number 2, 25% of a circle. Now this one is a more familiar one to work with because it's just 25%. So I'm going to keep this formula at the top of your screen. So to calculate 25% of a circle into degrees, we're going to put our percent over 100 We do not know how many degrees we have yet, and we're going to put it over 360. Now, from there, we're just going to cross multiply. So 100 times x is 100x. And using that calculator, 360 times 25 should give me 9,000. Now, we're going to divide both sides by 100 to solve for x. And x for this one is going to be 90. Now, to be more specific, 90 degrees. All right, and that's as simple as it is with converting percentages into degrees of a circle. All right, the next piece, we've got part E, F, and G, and we are done for today. Part E says, and this is kind of a lengthy part to write, so I apologize in advance. Part E says, how do you make a circle graph from a table? You're going to see some table displays in this unit tonight, and we're going to have to take the tables and create from the table a circle graph. So I'm going to give you just a couple steps on how that works. To create a circle graph from a table, step 1, if percents are given, it's going to be fairly simple. Use the circle graph in part B to estimate your sectors. If they already give you your percents, you're going to be able to start kind of drawing those sectors. And when I say use the circle graph in part B to estimate your sectors, well, if it's 50%, it's going to be half of a circle. If it's a 25%, it's going to be half of the circle. And anything close to these, you're just going to estimate how big that sector is. And when we do our first few examples and notes, it's going to make more sense. Now, what if the percents are not given? Step 2. If the percents are not given, you will need to find them by using the proportion. If I don't give you the percentages, and you're going to have to find the percentages on your own, you're going to use the proportion. I hope I can slide this up high enough. You're going to use the proportion. Percent over 100 equals part over total. Percent over 100 equals part over total. All right, so when we get ready to do part F and G, this formula is going to come in handy. All right, part F. I'm going to slide this up. Section F says convert the table into a circle graph. Part F. Convert the table into a circle graph. So here is the table that I want to give you for part F. This table is discussing students and the different foreign languages that they take at school. Now, in this table, 50 of them take Spanish, 16 of them take French, 4 of them take German, and 10 of them take another language other than one of those 3. So we've got to take this and convert it into a circle graph. But to do that, you've got to convert everything into a percentage first. So I want to show you how this works. So I'm going to go ahead and work on the Spanish students. So if I want to convert this into percents, I'm going to do percent over 100 equals part over total. So I don't know the percentage yet. So my percentage is X, always over 100, equals part over total. Now, what part of my kids take Spanish? Well, it says here 50 of them take Spanish. But out of what total, right? So to know the total, we're going to have to add all of these up. So I'm going to add 50. Watch this. We're going to do this right here. We're going to add 50 students plus 16 plus 10 plus 4. So to get my total students, we're going to go ahead and add to get 10, carry a 1, 5, 6, 7. There's 80 students total in this data. So 50 out of the 80 total, and I think that that total is important enough. I'm going to have you highlight this total in your notes. So there's 50 out of 80 that take Spanish. Now, to get my percentage, we're going to cross multiply. 80 times X is 80X. 100 times 50 is 5,000. Divide both sides by 80. Now, this is going to give me my percentage as soon as I divide. So we're going to take 5,000 divided by 80. That should give me 62.5%. So 62.5% are Spanish. All right, there's Spanish. Now, notice I have not yet created my circle graph. All we're doing right now is just getting the percentages. Okay, so now I want to take my French students, and I'm going to label my French students right here. A lot of busy work for this table. Now, to get the percentage again, it's percent, which we don't know, percent over 100 equals part over total. Well, what part of my kids take French? 16. Over what was my total number of students altogether? 80. All right, we're ready to do this again. So 80 times x is 80x. 16 times 100 is 1600. To solve for x, we're going to divide both sides by 80. And x should equal, let me see here, 20. So that's going to be 20% for French. Okay, we got 2 more to do. Let's do the other category. How many students take an other language? So again, it is percent, which we don't know, percent over 100 equals, how many were in the other category? 10? 10 over my total amount, which was right here again, 10 over 80. We're going to cross multiply to get 80x is equal to 1,000. Now we're going to divide both sides by 80. All right, you've got the calculators, so do I. Let's get this typed in. We're going to do 1,000 divided by 80. And that's going to give me a little tiny 12.5%. All right, the only other one we have to deal with is this language of German. I think that's right here. So to do German, who takes German, right? To do German, we're going to do percent over 100. We don't know the percentage, so that's our x. And it's only 4 students out of this display that are taking German out of a total of 80 students. So we've got the proportion one last time. We're going to cross multiply. 80 times x is 80x. 100 times 4 is 400. We're going to divide both sides by 80. 80s are going to cancel. And my percentage for the German goers is, I think, just a tiny little 5%. All right, so we have what we need to create the circle graph. Now we need to make the graph. So what I'm going to do right here, give me a minute. I'm going to just keep our information right here. And we're going to go ahead and begin creating the circle graph. But before I do, let's kind of revise what we have here. We've got Spanish turned into, what did we have? 62.5%. So Spanish is 62.5%. German was 5%. And all I'm doing is just reorganizing this. German is only 5%. The other category was 12.5%. And I'll show you what I'm doing in just a minute. And then the only other language I think up here was French. And French we had up here was it 20%? Yeah. Okay, so I'm going to move all this busy work out of the way. Here's our result. Now, if we did all of our calculations correct, this should total up to 100%, right? Let's just kind of double check and make sure that that adds up to 100%. So we've got 62.5 plus 5 plus 12.5 plus 20. Good, I'm glad it added up to 100%. So now we can kind of calculate and estimate just what our circle graph's going to look like. So I'm going to move that out of the way. Carefully, I'm going to sketch out a circle, give it a center point. Now, we know 50% looks like this, right? But we've got to calculate 62.5%. So 62.5 should be a little more than half. So I'm going to make this and this, I'm going to make this my Spanish language. I'm going to write Spanish there. And again, I am just estimating how big that chunk is going to be. I know it's going to be more than 50%. All right, so that one's done. 5% is something super tiny, so I'm going to go 5%. And I'm going to label that 5%, was it German? So I'm going to squeeze in here 5%. But out here, I'm going to write German. I don't have enough room on the inside. All right, 12.5%. We actually have a 12.5% in your notes, I think. The 12.5% in notes, if you go back to this, 12.5% is half of a quarter. So a quarter looks like this, right? This would be a quarter. So half of that would be 12.5%. And that 12.5% is the other category. And so what is left is this chunk right here, which is going to represent 20% of the data, which is French. And again, your sectors are just estimations, but they need to be close to estimations. And how do you estimate how big each sector is? I would go by these four here. You know what 12.5 looks like. It's half of a half. 25% is exactly half of a half. And then 50% is half of the circle. All right, this diagram, you may have to go back in this piece of the video. You may have to go back and rewatch when creating your circle graphs tonight. All right, there's one last piece of notes for today. So we're going to come back up to part G. And part G says, how can a circle graph help to make a prediction? And we have seen this word prediction even in the last section. So how can a circle graph help to make a prediction? So circle graphs are used to make predictions, and here's how it works. When you make a prediction from a circle graph, you do want to use this proportion right here, and we've seen this earlier. Percent over 100 equals part over total. Percent over 100 equals, again, part over total. So this is something that you might see in homework tonight, and this example is going to be the perfect one to look back on for help with it. All right, so this example says favorite fruits, and in this circle graph, 45% of the people surveyed liked bananas as their favorite, 25% had oranges as their favorite fruit, 12% liked apples, and 18% liked grapes. Now, here's the type of prediction problem that you're going to see tonight. It's going to say something very similar to this. How many of the next 80 people, I'm going to highlight the 80, how many of the next 80 people do you expect, and I highlighted that as well. The word expect just means to predict. Expect and predict are the same thing. That means you're using this formula. How many of the next 80 people do you expect to have grapes as their favorite fruit? So to do this prediction problem, you're going to use the percentage proportion up there, which reads percent over 100 equals part over total. All right, so do we even have a percent for this one? So let's look at the circle graph. It says, how many of the next people do you expect to have grapes as their favorite? So when you look at grapes, which is right here, we have our percentage. It's 18%. So I'm going to put 18 over 100 equals. All right, now we've got to do this idea of part over total. So what part of the people like grapes? Do we know? Or do we know how many total people surveyed like grapes? So that's when this number comes into play. How many of the next 80 people do you expect to have grapes as their favorite? The number you are given here is the total number of people that they are trying to survey. So this number here given will always be the total. Now, 18% of them is how much? Well, that's the part that we don't know. That's where the variable goes. So now that you have your formula, you're going to cross multiply. 100 times x, again, is 100x. And 80 times 18, I have no idea. We are using a calculator to get that quickly for our notes. That's 1,440. Divide both sides by 100. And X is equal to 14.4 people, which sounds very odd. I would be okay if you estimated that to 14 people. So both of these answers are acceptable. This is the actual amount. We know that you cannot have 4/10 of a person. So if we were to round that, we would say 14 people are estimated out of the 80 to like bananas. All right, good luck on this assignment tonight, and we will see you in class tomorrow.